Welcome to Learn with Jabe. I'm Jabe Manelli, no relation to John. And this week we're going to dig deeper into what the farts the in-place parameter actually does within Pandas. If you've ever found yourself copy pasting Pandas code from Stack Overflow, then you may have run into our dear old friend, the in-place parameter. At first glance, it probably looks like a seemingly random parameter popping up here and there, but more often hiding in the background, defaulting to false. When I was starting to learn pandas, I never once encountered an explanation for that in-place parameter and what it truly was or what it was used for. Fast forward to present day, and I believe I can finally help others on their pandas journey to grasp the concept once and for all. But let's get back to why you're here, and that's to learn the in-place parameter. And today, we're going to be using NBA stats to wrap our heads around it. So for all you NBA junkies out there, bon appetit. At its core, the in-place parameter helps you decide how you want to affect the underlying data of the pandas object. Do you want to make a change to the data frame object you're working on and overwrite what was there before? Or do you want to make a copy of the data frame object and assign it to a different variable so you can modify that original data later? Those are the two questions you need to ask yourself. Your answers will help you determine if you need to set the in-place parameter to true or false. Now, to help explain it further, let's see it in action. We'll run through an example using NBA stats because, well, ball is life. Now let's read in a data frame with the 2020-2021 per game stats, which we grabbed from stats.nba.com by hitting the API endpoint. We'll go into a little more detail in another video on how we did this exactly. We can use the read CSV method and save it as a data frame called df. Now we'll filter the data frame to contain only the Los Angeles Lakers players since they are the reigning champs and we should respect the champs. We can print the data frame, which we've saved as df, by putting it as the last line in the Jupyter Notebook cell. If you look at the output below, you'll see the data frame is sorted in alphabetical order based on player names. So we have Alex Caruso first and Wesley Matthews last. It's going on the first name. So you have A's, then D's, J's, K's, L, shout out LeBron, all the way to W. Now, let's say we wanted to sort our data frame by the points per game column, which we can see right now is not sorted. We're going to sort it with the highest points per game average at the top. To do this, we can use the sort values method. So what we see is the player name is no longer in alphabetical order, and the points are sorted from highest to lowest. So you have LeBron James at the top of the food chain, averaging nearly 26 points per game, and Jared Dudley at the bottom, averaging 0.5 points per game. Great. Mission accomplished. It looks like the data frame is sorted by the points column. But what happens if I print the data frame object again in the next notebook cell? Would I still see the same ordering with LeBron on top? Let's do it. No, I no longer see the points column in descending order. And the player name is again in alphabetical order, right? Where Alex Caruso is back at the top. It basically reverted back. Now, why did it do it? The reason is this. Whenever you modify a data frame, and what I mean by modify, aka make a change to it, the new modified data frame doesn't exist until you assign it to something. Until that moment, it is merely in the memory. This is often why you see the common workaround to using the in-place parameter, which is saving the data frame back to the same data frame variable. Let's sort the values again by points, then assign it back to the df variable and print df. This time, when we print df, it prints it in order of the highest to lowest points. This is because we modified the data by sorting the value and then assigned it back to a df variable, which was just overwriting the original one. So, where does the in-place parameter come into play? Well, let's clear our notebook right now. So we're basically starting from 0. And then we'll run our original cell to read in the data and to filter the Lakers data frame. And only this time, we're going to go through that same point sorting. However, we are going to use the in-place parameter and set it equal to true. Now, if we print df in this next cell, we'd expect to get the unsorted Lakers data frame again since we haven't assigned it to any variable. But look what happens when we print it. The data frame is still sorted by points. Aha! The magical in-place parameter at work. It's assigning the variable even without us assigning it to another variable. So basically we asked ourselves, do you want to make a change to that data frame object you're working on and overwrite what was there before? And we answered yes. Hence why we set the in-place parameter equal to true. Again, we told the original data frame it was okay to update itself using the points in descending order sort values change. We didn't need to assign it to any variable. We modified the data frame in place. The flip side of this means that every time we don't set the in-place parameter equal to true, it is set to false by default. Let's go through this exercise one final time, making sure to call out the in-place parameter and setting it equal to false for good measure. We'll use the same code as we did the first time around, but we'll make sure to set the in-place parameter equal to false explicitly. So if we print this data frame, what do we expect to get? Let's run through it. It gives us the same results as before, where the player name is still in alphabetical order, but the points is not. So you see what happens? The df object, the data frame object, remains unchanged. That means this is identical to our first attempt. We just didn't need to call out the in-place parameter since it is false by default. What could happen here is we could take the same code, copy it, and set it equal to this new df new. And if we then printed this new df, since we're overwriting it or creating a new variable, we're going to get at the points in descending order. So to sum it up nicely for you, you can think of the true and false setting for the in-place parameter as follows. When in-place equal true, the data is modified in place, which means it will return nothing and the data frame is now updated. Be careful here though, because you can't go back or revert to what the original data frame was. You're basically saying update this and use this new filtered, sorted by data frame from here on out going forward. When in place is false, which is the default, keep in mind, which is why you might not see it always called out as the parameter, then the operation is performed and returns a copy of the object. You then need to save it to something. That something can be a new variable or the same variable name. Keeping in mind, if it's the same variable name, it's going to override it. Well, that's all I have for you. This is Jade Manelli signing off.